Quantum mechanics explores how particles, like electrons and photons, behave at the smallest scales of the universe. At the quantum level, particles like electrons can behave as both waves and particles, depending on how we observe them. The double-slit experiment shows that light and matter can behave like waves, creating patterns of interference. In superposition, a particle can exist in multiple states at the same time until it's observed or measured. Schrödinger's cat is a thought experiment where the cat is both alive and dead until observed, illustrating superposition. Quantum entanglement links two particles, allowing them to affect each other instantly, no matter the distance between them. The uncertainty principle states that the more precisely we measure a particle's position, the less we know about its momentum. In the quantum vacuum, particles appear and vanish randomly, creating energy fluctuations that define the quantum realm. Quantum tunneling allows particles to pass through barriers that they wouldn't be able to cross in classical physics. Quantum computers use qubits, which can be in multiple states at once, offering massive potential for future technology. Quantum foam is the idea that at the smallest scales, space-time itself fluctuates, bubbling with energy and particles. Quantum effects shape everything around us, but their influence fades as we move to larger, classical systems. Quantum decoherence explains why quantum superposition disappears as particles interact with their environment. The many worlds interpretation suggests that every quantum event creates new parallel universes, each with different outcomes.